Number 4. We're looking at a logarithmic equation. So my goal is to get x by itself, find a solution for x. So I notice here that it is a log, part of a log. So my first step is to isolate the log. Now remember, the entirety of the log is the word log, the base, which in this case is 2, and the argument, which in this case is the entirety of x squared minus 7x minus 7. That is the argument. So this is our entire log, and it is already isolated. So I can go ahead and skip step 1. Step 2 tells us to get rid of the log, do opposite operation. Opposite operation of log is exponential, so you have to exponentiate both sides, keeping the same base. So I do a big base of 2 on both sides, and the entire log is now in the exponent. Now 2 raised to the power of log base 2 cancels to be 1, so you're left with, on this left-hand side, the argument. X squared minus 7x minus 7 is equal to 2 raised to the power of 0. Now, anything raised to the 0 power is 1. So 2 raised to the power of 0 is equal to 1. Whoops. Now notice, this is now a quadratic equation. We solve quadratic equations by getting everything to one side and putting it into standard form. So I need to move this 1 to the left-hand side. I do that by subtracting 1 from both sides. So I have x squared minus 7x minus 8 is equal to 0. And we solve quadratics by looking to factor first. So I create my little x over to the side. Let's do a different color. A times c goes up top. So I have a times c, which notice there is no a, so I do not need to, in the end, look for fake factors. A times c is just negative 8, and b is negative 7. And you ask yourself, what multiplies to be negative 8 but adds to be negative 7? Well, negative 8 and positive 1 multiply to be negative 8 but add to be negative 7. And these are true factors because I do not have an a value. So I can just go ahead and write these down as my factors. These are my factors, but I'm trying to find solutions here. So what you need to do to go from factors to solutions is set each factor equal to 0. Then you get x by itself. So I'm going to add 8 over, meaning my first solution is 8. And then I need to subtract 1 over, meaning my second solution is negative 1. Now before I can circle these and be done, I must check each one of these solutions, meaning I need to plug each one back in for x of the original equation. So I have log base 2 of, now I'm going to plug 8 in first. So I have 8 squared minus 7 times 8 minus 7 is equal to 0. Now I first need to evaluate this log, but in order to do that, I need to have the argument be that one term. So I'm going to simplify this argument down. 8 squared is 64 minus 56 is 8 minus 7 is 1. So let me write that out. 64 minus 56 minus 7. Oh, what happened? Ends up being 1. So you ask yourself, when we're evaluating this log, what power do you raise 2 to be 1? You raise 2 to the power of 0 to equal 1. Anything raised to the power of 0 is 1. So this log evaluates to be 0. And the left-hand side is equal to the right-hand side, meaning 8 is a valid solution. Now I must check the second solution of negative 1. Log base 2 of negative 1 squared minus 7 times negative 1 minus 7 equals 0. Now, in order to evaluate this log, I have to have one term as our argument. So I'm going to simplify this argument down. Negative 1 squared is 1. Oh, still have green. So negative 1 squared is 1. Then negative 7 times negative 1 makes it a positive 7. And I bring down that negative 7. So 1 plus 7 is 8. Minus 7 is 1. So now I have one term as our argument. I can evaluate the log. In order to evaluate the log, you ask yourself, what power do you raise 2 to be 1? You raise 2 to the power of 0 to equal 1. So this log evaluates to be 0. And our left-hand side is equal to our right-hand side, meaning this is a valid and true solution.